Okay, here we go. Here's your introduction, differential calculus. So this is where the term comes from, differential calculus, that we find derivatives. And a differentials relates to the word derivative. Definition of derivative, if you look it up, it says something that is based on another source. So, you know, how about this? Region Reyes is a derivative of Black Sabbath. There you go. So, Region, do you play music by Black Sabbath? Are you Black Sabbath? As the music of Black Sabbath changed over history, maybe your music changes too because you try to model it. Sure, something like that maybe. So in terms of X and Y, okay, here's how we talk about that. The change in Y with respect to the change in X. What does that sound like? Slope. Yeah, very good. So other words or phrases that imply derivative. Now, this is not what the word derivative means mathematically, but this implies the same type of thing. Slope would be one. Rate of change would be another. Do you think of anything else? Cause and effect. I say average rate. I'm going to write one more. Instantaneous. Instantaneous rate. So, you know that slopes, it's the slope of the tangent line to the function that we're primarily concerned about, correct? So you tell me, is average rate of change referring to the slope of the secant line or of the tangent line? Secant, because you have how many points for average rate of change? 2 points, but instantaneous rate of change implies that there's how many points? 1, so you have slope at 1 point. So really, a derivative is going to be that instantaneous rate of change at a given point. Now, mathematically, we can define exactly what the rate of change is of a given function, f, at a number a, and it's denoted by this. This is not new. We're just putting forth the terminology now. You got to understand that calculus existed for thousands of years, but people weren't able to actually put it in a way that you could understand, teach, learn, and work with it. And when that finally happened, it was really beautiful. And so this is what we get. Slope. That deserves a round of applause. I really think that was amazing. Maybe we have an encore. Okay. All right. Cool. There was a... Can I say what happened to YouTube Nation? So, Casey belched. And it wasn't quiet either. I'm surprised that some people did not hear it, but that was awesome. I'll tell you what, it was cool enough where if you need a belch again, please do it. No, just Casey, okay? All right. Some of you guys had garlic last night for supper. I don't want to smell that. So here we go. M equals. I'm gonna put this in there. Remember we talked about that yesterday? If you see f prime, that's a way of saying the derivative. So the slope at a given point on the function is equal to the derivative at that spot, which is equal to the limit as h approaches 0 of what? A plus h. Minus f of a all over H. What does H represent? H represents the distance between the those two lines. So you got the distance between the 2 points, the secant line. We're going to move those to 0 to make it the tangent line. This is your slope formula. Okay? And so, here we go. For the function f of x, arrange the values in increasing order. F prime of negative 4, f prime of negative 3, f prime of negative 1, f prime of 1, and f prime of 3. So this is my function, f of x. You might say, well, Mr. Gens, I don't know the exact value. Great, it doesn't tell you find the exact value. It says estimate it and put it in order. So f prime of negative 4, look at negative 4. Right here is the slope. First tell me this. At negative 4, does the function itself have a positive or a negative value? The function has a positive value. The function is above the x-axis. The function is positive. Is the derivative positive or negative? Why? Because the instantaneous rate of change, the slope of the tangent line at that given point, is in fact negative. And I'm just going to write here, very negative. So I know that that's not a, if you would like to ascribe a number to it, go ahead. We could, kind of look at, let's see. Negative 7. That's a guess. Negative 7. Good, Larry. You can kind of eyeball it and say, well, if I go over 1, it looks like I go down about 7. Sure, that's fine. Okay. F prime of negative 3. The function value at negative 3 is positive or negative? It is negative. What is the derivative at negative 3? What is the slope? 0. Yeah, if you were to sketch a tangent line at that spot, it would have a slope of 0. F prime of negative 1. Does the function have a positive or negative value at negative 1? Positive. Is the derivative positive or negative? Positive. In fact, what would you estimate it to be possibly? Sure. 1 sounds good. So, as we estimate the slope, we're just drawing a tangent line and we're saying what appears to be the slope of that line. And it's just a ballpark answer. Would you think 1 is a reasonable estimate? 1 would be at about a 45-degree angle? I think that that's fair. F prime of 1. The function is positive or negative at 1? It is positive. Is f prime positive or negative? Negative. You can tell by looking at it, and if I draw the tangent line, I would say negative 1 is an excellent estimation. F prime of 3. If you plug in 3 to the function, you get a positive or negative value. Positive. It's very positive. Give me a number that you think would be a good estimation. Sure, 7 or 6 or something like that. Great. Very positive. So you can tell now that as you just look at it, it's the difference between knowing the value of the function and the value of the derivative. So are you looking at the function or the slope? If it says f prime, you're looking for the slope. So it says arrange them in increasing order. So I need to put the smallest one first. What's the smallest one? F prime of negative 4 is less than what? F prime of negative 1? Or, yeah, oh yeah, you did the same thing. All right. There you go. Which is less than F prime of negative 3. Which is less than. Which is less than. Any questions how I came up with those values? Could you do that on the test? So, as I look at, say, f prime of negative 3, I find negative 3, and I look at the graph at that spot. Well, I made this is a guess. This is approximate. Do you see how the slope at -3 is 0? Okay, well, if you want to guess this, then you could say go over 1 and up 1, 2, 3. So 3 would be a fine guess as well. 4 would be a fine guess. You know, just knowing that it's definitely different from the others. Yes. You won't have that situation. The question is, what would you do if you had two that were the same? And we'll make sure that there's a clear distinction. You know, we're not going to, for example, if you had, you know, 2.5, for example, that might look really close to -1. And we're not going to give you that type of a problem. We don't want you to be in that scenario. Exactly. The bigger slope and the bigger value of the derivative. Exactly. Flip it on over. Good. Good job, everybody. Okay, you're welcome. If the tangent line to y equals f of x at -2, 3 passes through the point 1, 9, find f of -2 and f prime of -2. Oh boy. Do you have any idea what that's saying? No. So if you don't know what it's saying, draw a picture to help yourself out. Now you can put your picture right there. I'm going to draw one here. And again, the information says as follows. Hey, TV, how you doing, buddy? Glad to have you back. Well, I am. I don't know how the rest of the class feels. Are you guys excited to see Tyler? Okay, they are. Yes. Yeah, I'll bring her in. We can just look at her. All right. All right. There's a function, and at -2, 3, it has a tangent line that passes through 1, 9. So here's what I'm going to do. I'm going to draw myself a little picture just so we can get a visual of what's happening. Okay, so I'm going to go back 1, 2, up 1, 2, 3, 4, 5, 6, 7, 8, 9. So the function has a value at -2, +3. It goes through that spot, right? And it says that the tangent line at that spot of the function ends up going through eventually 1, +9. Does everybody agree that that appears to be the line tangent? Now, do you see a function? I don't see a function either. I'll draw one. We don't know necessarily the rest of the behavior of the function. All we know is that it does go through that point, and it has a slope. You know, so we can do whatever we want with it. Okay, there we go. There's your graph. It doesn't really matter, does it? We just need it to have a slope right there. So the two things we want to identify are f of -2, f of -2, and we want to know f prime of -2. So the question is, first, this one should hopefully be obvious. What is f of -2? 3. If you plug -2 in, you get an output of 3. That's what that means. What does f prime of -2 mean? It means the slope of the tangent line. Do we have enough information to find the slope of the tangent line? We sure do. Okay? Exactly. 9 minus 3 over 1 minus -2, and you get 6 over. Now, again, the reason why I drew all those pictures is not because you have to draw all those pictures, but rather because I wanted to help you give an idea of what we're trying to do. Is there any questions about that? Could I have drawn the function so that it looked like this green representation right here. Could I have done this instead? Sure could. I know the slope's positive because, look, you have the tangent line right here. And it goes, as you move to the right, it goes up. It doesn't matter whether the function, well, in either way, the function's increasing at that spot. Okay, let's try the next one. It says, sketch a graph of a function where f of 0 is 4, where f prime of 0 is 1, where f of 1 is 0, and where f prime of 2 is negative 3. You help me understand. Let's first interpret what each one of those means. What does the first one in black mean? What does that mean? Good. We have the point 0, 4. Good. What does the green one mean? There's a point at 1, 0. What does the red one mean? The slope is 1 at x equals 0. That's what the red one means. What does the blue one mean? The slope is at x equals 2. So there's an infinite number of ways, to draw a graph that would have these type of characteristics. And we'll just draw one, and then I'll challenge you to draw one that's different. But we want to put a point at 0, 4. 1, 2, 3, 4. And let's see, 1, 2, 3. I'll use blue for my graph. Got a point at 0, 4, so I have to go through that. I also have to travel through what point? 1, 0. Now, so I've taken care of two of the issues. The graph has a slope of what at 0, 4? Has a slope of 1. Okay? Watch what I'm going to do. Do like that. Does that have a slope of 1? Sure does. What kind of function am I drawing? Piecewise. Sure, I can do that. And then at 2, I have to have a slope of negative 3. So at 2, I have to have a slope of negative 3. So how about I just draw this with a slope of negative 3 the whole time? Does that satisfy the requirements? At 0, the function has a value of 4. At 0, it has a slope of 1. If you wanted to carry it on for a little bit more and put an open circle, that would be fine as well. You could curve it down exactly. That's what most people want to do. What most people want to do is they want to do something like this. They want to do that, and then they want to bring it down like that. That'll be fine too. So the red one's a representation that you could have. There's an infinite number of ways to draw this. I'll do another one in green. In green, I'll draw. We'll go like this. We'll go open circle to here, and then we'll fill this. To there, and then I will draw it at a slope of negative 3 there. There's an infinite number of ways to express this. The point is that you have to understand what each of these means and verify that it does in fact work. Okay? Is there a question? You guys want to try it on your own? Okay, so flip to the back side of your notes. Do you have some space on the back? Okay, so on the back, here you go. the backside takes hardly any space. So just draw a line for half, and we'll have you doing. Okay. So draw a graph, and so make a x and y axis, and you can practice with. Draw f of x given. So I'm making this up top of my head. So let me quick think about it. We'll say that f of -2 is 1. F prime of -2 is equal to -1. As soon as you see prime, that means slope. The slope at -2 is equal to 1. -1, excuse me. We'll say f of 0 is equal to 3. And we'll say that f prime of 0 is equal to 1. See if you can fulfill those 4 requirements and draw a graph. And when you think you got a graph, come and put it up on the board so we can all look at it and see how beautiful it really is. So let's go to the next one. Given the function f of x equals 1 minus x to the third, find the equation for the line tangent at 1, 0. What two things do you need to find an equation for a tangent line? Point on the line and slope. So now we're actually going to put this in practice. This is similar to what we've just done. What is the point on your line? 1, 0. So I do m equals the limit as h approaches 0 of f of, what is a? A is 1. So 1 minus 1 plus h to the third minus, what is f of a is 0 all over h. So m is the limit as h goes to 0 of, what is 1 plus h to the third? Remember Pascal's triangle? We have a 1, 3, 3, 1. What happens to the 1s? They cancel. What can you do with an h? So you have m equals the limit as h goes to 0 of negative h squared minus 3h minus 3. Can you now plug in your 0? And what do you get? Negative 3. So now we can write an equation if we want to. That's what we'll pick up tomorrow, okay?